This is a spec for the module on scientific notation. We'd want to write this in black. Express in scientific notation. And we'll give them numbers both greater than 1 and less than 1. And then we'll also do it the other way. We'll give it the scientific notation, and then they have to choose the decimal notation. So for the ones where we give them the decimal notation, and they have to go to scientific, one example might be the number 3952000. And so the first hint here will be, there are 1, 2, 3, 4, 5, 6. There are 6 digits, and we could do the 6 in a different color ideally. There are 6 digits, to the right of the leading 3, and to the left of the decimal, So 3952000 is equal to, and we could even put the leading 3 here. The leading 3, we could do it in green, is equal to 3.952 times 10 to the 6th power. And for the different choices, we obviously might put the correct choice, we have to put the correct choice, 3.952 times 10 to the 6th. And we could do different variations, 3.952 times 10 to the, maybe they count that number, 10 to the 7th. And maybe they want to put the decimal in front, so 0.3952 times 10 to the, and this would actually be the same, this would actually be an accurate answer. It is the same number, it's just not in scientific notation, because this number right here is less than 1. You could also do 39.52 times 10 to the 5th. Once again, the same number. It's mathematically correct, but not in scientific notation. And then you could do something like 3.952 times 10 to the negative 6, just to confuse them. And we could add many, many more types of choices that might randomly be put in here. So that's the situation where the number is greater than 1. Let's think about the situation where the number is less than 1. So let's clear this. Let's clear that. And then let me clear the choices for now. Let me clear that over there. All right, so this would be the situation where we have a number less than 1. So 0.0065. And so we could say the first hint is say count the zeros to the right of the decimal before the leading 6. And you say including so we could say, well, we could say we have 2 zeros. We have 2 zeros. Including the leading 6, we have, including the leading 6 and the zeros, we have 3 digits to the right of the decimal. So the last hint is, so 0.0065 is equal to 6 and we might want to once again color code it, leading 6 right there, leading 6, same color. So it's equal to, and even here we might want to do it. If it's too difficult, don't worry about it. It's equal to 6.5 times 10 to the times 10 to the, so there's a 3 here, times 10 to the negative 3. And so we could put the choices here. The correct answer might be, 6.5 times 10 to the negative 3. Maybe we do 6.5 times 10 to the negative 2. Maybe we have 6.5 times 10 to the third. 6.5 times 10 squared. Maybe 0.65 times 10 to the negative 2. All of those, and we could add many, many, many more choices there. Now, if we want to do the reverse, where we give the scientific notation, we ask for the decimal notation. And these on some level will be easier. So we give, edit, so let's clear it. So we can say, express in decimal notation. Or even better, we don't even have to do that. We could just write it out like, where we give someone, let's say we give them 4.72 times 10 to the fourth equals question mark. So the first hint we can do is 4.72 times 10 to the fourth is equal to 4.72 times 10,000, which is equal to, and then the next hint maybe we could say is 4.72 times 10,000 is equal to 47,200. And so that might be one of the choices, 47,200. The other ones might be 4,720. Maybe we have 472,000. Maybe we have 4,720,000. Maybe we have 472 here. So that's the situation where we have a positive exponent. We could also have a negative exponent. Let's say we had the situation where it was 4.72 times 10 to the negative 4. And we want to range this so we don't get too ridiculous large numbers. Maybe this should be between positive 6 and negative 6. So if this is a negative 4, we'd say this is the first hint is be equal to 4.72 times, or we could say this. We could say it this way. 4.72 times 10 to the negative 4. And if you want, you could color code 10 to the negative 4. But if it's too much trouble, don't worry about it right now. Which would be equal to 4.72 times 10 to the negative 4 is 0.0001. And the next hint is 4.72 times 0.0001 is equal to 0.000472. And so you'd have 0.000472 as one choice. You have 0.472 over here. Maybe you have 4,000. Maybe you have 47,020. 47,200, just in case they thought that was a positive exponent. Maybe you have 0.00472, just to confuse them. 0.000472, and you could have a wide range of things there. So hopefully that's enough information, and you can hack away on this module.